Right. So what if the circuit contains dependent sources? How can I use superposition to do that? So I'll explain this with an example, but simply speaking, in this circuit in here, I have a current source and a voltage source that are independent, and I have a dependent current source and a dependent voltage source. In superposition, what it turns out to be that dependent sources, they stay on all the time. You can't just turn them off. So what we're going to do to analyze this circuit is we're going to turn off this source and keep this one on, and then the next one we're going to turn this off and keep this one on. And in both cases, the dependent sources will stay on all the time. And of course, if this, for example, depends on V delta in here, that means in the first circuit, this will depend on V delta, and this is V delta prime, a subset of these V deltas. So the V deltas change when based on the subcircuits. Again, when you turn off a source, you just basically take a look at the subcircuit that results, or the new circuit that results, and just treat it as a circuit on its own. So all the voltages, all the currents, like everything changes, and they're not exactly the same as the original V delta. So let me just do this. So I will start by saying like, well, let's, I believe I'm gonna turn off this source first, and then we'll keep this on at the beginning. Okay, so let me just redraw that circuit. So that circuit will look something like this. So this is here, the plus, the minus, this is 10 volts, and we have the 5 ohms in here, and we have 20 ohms in here, and I'll keep this one here. This is plus minus V naught, because actually what we're being asked to compute is this particular V naught, so we're gonna have to track it, and this, in this particular case, is V naught prime. So let me just do that here in red. This is V naught prime. Okay, because this is the first of the two circuits. And also I want to track that this one here is I delta, because it's one of the dependent sources will depend on it, which is this one here, but this is not actual I delta, this is I delta prime. It's not like the original, so we have to distinguish. All right, so we do that in here, and I believe this current source, it's a dependent current source, so it stays on, and it depends on 0.4 V delta prime, and we'll see where that V delta prime, it's actually across this 10 ohms in here. Okay, so this 10 ohms in here will have plus minus V delta prime. All right, and then we have a voltage source in here, and that particular voltage source plus minus in here, it depends on 2 I delta prime. This is the I delta prime that we got in here. Okay, and then it connects in here, and I believe the last one we can leave it open because technically it's an open circuit in here, so I don't need to draw these two wires. Okay, so this is the sub-circuit that results, and if you take a look at it, what I'm being asked to compute is that particular V naught in here. So I can of course write nodal or mesh, or in this particular case, I think these are the two only options I have. If I'm to write mesh, well, let me just do a quick analysis in here. Well, I have two essential nodes. That means I have to write one nodal equation in here. But if I'm to write mesh, I'll have to write a mesh current in here and a mesh current in here. And frankly speaking, well, I know this one here based on this particular current, so I'll end up with one mesh. So either way is fine. I think you'd end up with just one equation, and you have to deal with the dependent sources. But because I'm looking for V naught or V naught prime, I'm going to deal with it as well. I'm going to put my reference in here, and that the voltage in here will be V naught prime, the voltage I'm looking for. So I'm going to write nodal equation in here. Okay, so we write nodal equation. Let me just write it in here. And again, I'm just hiding the original circuit because this is how you have to deal with the new circuit. You have to deal with it as if it's completely new. The V delta, I delta, they have nothing to do with the original. Okay, and this is one of the most common mistakes that I've seen new learners make is, well, if they compute the V delta in the original circuit, they just keep using them in here. They're not. This is just a new circuit, and you have to analyze it this way. All right, so let me write the nodal analysis. Nodal analysis tell me V naught prime minus 10 divided by 5 plus V naught prime divided by 2 negative, well, this one here, it's a current source, so all I have to do is just, well, I'm looking for the opposite of it, which is negative 0.4 V delta prime, and that should be equal to 0. So V delta is not one of the nodal voltages that I'm looking for, so I have to write the equation. Where's the V delta? V delta is here, so I have to just figure out what that V delta is so that I can substitute it in here in terms of V naught. So let me just do that. So what is V delta? Well, V delta is based on this current. So I have a current in here, and that current happened to be 0.4 V delta prime. And based on Ohm's law, I can just simply say V delta prime is just simply 10 ohms times 0.4 V delta prime. It just happened to be that the current is 0.4 times V delta prime. That's the current because I have a dependent current source. Okay, so that is simply for V delta prime and V delta prime, and based on algebra, this V delta prime is just simply 0. That's what it is. So all I have to do is just substitute these with a 0, and I'll end up with V naught equals 8 volts. That will be the V naught. That is the effect of the voltage source alone. Okay. All right. So we have figured out what the effect of this source in here on that V naught, and it happened to be 8 volts. Okay. So now what do we do? Well, the next go around, we're going to turn this source off and this back on. So let me just highlight it. We're going to turn this source off and the other one is on, and we just basically redraw the circuit based on that. So let me just draw that circuit in here. So basically turning off at 10 volts is just replacing it with a short circuit wire. Okay. Then this one here stays 5 ohms. This one here stays at 20 ohms. Okay. 20 ohms. And then what do we have in here? We have the dependent current source in here. That will be 0.4 V delta prime. Okay, and of course this one here is now I delta prime because it's different than I delta prime and it's different than I delta. And this one here is the voltage that we're looking for, which is V out or V naught prime. And we have dependent voltage source that's plus minus, and it's 2I delta. You have to pay attention, it's prime as well. All right, and then here we have, I believe the 10 ohm stays the same, and that's plus minus V delta prime, and this one here is 5 ohm or 5 amps, sorry. Okay, now what are we looking for? Well, we have to focus on this particular circuit now, regardless of what's happening in the other one. So focusing on this circuit alone, that's what we have to do. Well, what are we looking for? We're looking for this V naught prime. Okay, so we have to do a little bit of quick analysis to see whether we should use nodal or voltage, or nodal analysis or mesh analysis. So I have 1, 2, 3, and 4 essential nodes. I'll end up with 3 different nodal equations that I need to solve. Well, okay, so I'll end up with 3 nodal equations to solve. However, if I do mesh analysis, I'll end up with like one mesh in here. I'm going to write an equation for this. I don't need to write an equation for this because there's a current source in here, and I don't need to write an equation. So I'll end up with one mesh analysis network. So I'll end up with mesh analysis. I think mesh is just simpler, just because I know the current in here and I know the current in here, because these branch currents are the same as the mesh currents. So I'll end up with just one equation in here. All right, so let me just highlight these current in here. For example, I can just simply say this one here is I1, this one here is I2, this one here is I3. Okay, and we're going to start by I3 is just simply 5 amps. That's what it is because I know what it is. All right, let me just do that in blue. Okay. All right, so we know what that current is. All right, what about the I2? Well, simply I2 is just simply 0.4 V delta prime, because it's also based on this dependent current source. Okay, so we're gonna have to figure out what V delta prime is. Where is V delta prime? Well, V delta prime is here. It's the effective I3 and I2, so I'm gonna write it as such. So we have V delta prime is just simply 10 times I3 minus I2. Why is it I3 minus I2? Because the I3 is going to the positive and the I2 is going to the negative. All right, but we know, we know that I3 is 5, and what I want to do is I want to combine these two in here. So I'll take the V delta in here, and I'll of course put the 5 in here. All right, so let me just do that here. So I2 is just simply 0.4 times 10, okay, times I3, which is 5, minus I2. Okay, so we'll do the algebra, and hopefully you will see that the I2 is just simply, let me just do that. I2 is just simply 4 times 5 times basically, I believe it's negative 4 I2. So that means 5 I2 is just simply 20. That means I2 is just simply 4 amps. Okay, so we know what I2 is now. I2 is just 4 amps. All right. And that leaves us now with the third mesh, which is here. So let's write the mesh equation for that. And that will becomes 5I1 plus 20 I1 minus I2 equals 0. But I know what the value of I2 is. It's just simply 4. So that gives me 25 I1 negative 20 times 4, I believe. That should be equal to 0. That means I1 is just simply 20, which is 80 divided by 25, and that should be, let me just compute that. 80 divided by 25 is just simply 3.2 amps. Okay, so I know all the currents that I'm looking for. What I need to do is, well, what am I looking for? I'm looking for V naught here, V naught prime prime. Well, that simply can be computed in the following way. So V naught prime prime using mesh equation or mesh current is 20 times I2 minus I1. That's what it will be. And why is it I2? Because I2 is going to the positive and I1 is going to the negative. Okay, so we substitute with these two values, 2I2, which is 4 minus 3.2, and I should end up with the following, which is 20 times 4 minus 3.2. Okay, and that will be 16 volts. All right. So now this is the second voltage that I should care about, which is here. So now what we're looking for was V naught, and that's simply V naught prime plus V naught prime prime, which is just simply 8 plus 16, okay, and that will be 24 volts. Okay, again, just let me zoom out just to see what happened. So what we did is the following. We turned on this source and then turned this source off, and we ended up with the V naught prime is equal to 8 volts. And then in the opposite direction, now we turned this off, we kept this one on, and we ended up with 16 volts. So the voltage in here is the effect of both of these combined, and all we had to do is just sum them, and we ended up with 24 volts, and that's the value of V naught that we're looking for. Now we can compute the power if you wanted to. Do not compare it based on V naught and V naught prime. Okay, now we can compute the power. For example, if you were asked to compute what the power across that resistor is, you can just simply say the power is V naught squared divided by R, and that will be 24 squared divided by the value of R, where this happened to be 20, and the answer you get is that power, the correct power. Do not compare the power in here and the power in here. Just don't do that. Don't say P prime in here and P prime prime and just sum them. It doesn't work that way.